So we are going to simulate 2D metropolis, but before that, let's use the regular or formal analysis to verify our simulation. We'll just use 2022. So we need two sample sizes, one for sample 1, the other for sample 2. So, and one, they don't have to be the same. I'll call it 102, 150. The next we need is the true probabilities. So these are, you know, I'm going to teach you in a different way. Because, you know, you guys are advanced, that's an effective way of doing it. I'm going to create a list, a vector, right? This way we can access it using the index of the vector n. Next up, theta values. I'll call it theta or true dot theta. Sort of is redundant because in statistics, when we say parameter, it is implied that we're talking about the true value. So the true theta, I'm going to hit 0.78 and 0.59. So the success probability for the first sample, 0.78, second, 0.59. Guys can learn something new. So I'm going to create X as a matrix 0. So to use the matrix, we have to have the same dimension, right? We don't have the same dimension. So in this problem, not a big deal. I can still make the matrix work, because I'm dealing with only ones and zeros. And when I sum the row, I'm just going to sum the ones, not a big deal. But in other cases, if the sample sizes are different, we cannot use a matrix, we cannot use the data frame, we have to use an S3 object, which is a list. So since it is doable in this case, let's just go with the matrix. 0, and number of rows, I have 2 samples. Yes. Number of columns, the length of n, and I want it to be the maximum of 100 and 150. Correct? Because if I set the number of columns to be 100, I'll lose 50 observations in the second sample. So I'll set this as maximum of n. So let's quickly run this and see what we have. Source n 100, 150. True theta 0.8, 0.59. Now, when I type X, it's just going to do that. Too much to look at, yes. All 150 observation columns and 2 rows. Sometimes we just want to get a good peek or a sneak peek. So you can do head X or tail X. Since we have only 2 rows, it defeats the purpose because head X typically would pick the first 3 to 4 rows and display the matrix. When you do tail X, I believe it's 6, it could be 6. 6. So it's 6 rows, but I can't change it. So if I did head X m equals 1, it's just going to show the first row. Likewise, if you did tail X comma n equals 1, it'll just show the last row. Here it's moot point because we have the same only 2 rows and 150 columns. Now, we access matrices using square brackets. Because it's the way we defined this, we have to be careful. Even though the sample size that we created is, even though the matrix that we created is 2 rows by 150 columns, which is the maximum of the 2 sample sizes, when I create R binomial to generate a Bernoulli sample, M1, I'm accessing the first element of the vector n. I need to specify the number of trials, which is 1. We're talking about Bernoulli. Probability of success, true dot theta point of 1. Yes? So, but the issue here is I can't simply take this and assign to x square bracket 1 comma close square bracket y.
What were
So create 0 matrix, dimension 2 by 150. My question to you is, I can't simply generate that sample R binomial and assign it to x first row, x, y.
is it because they're different lengths?
Different lengths. So how do we make sure that we don't get that length error? So what should we do? What do we do in MATLAB?
Yeah.
Yeah.
We would keep on appending zeros.
We can append zeros, right? But an interesting thing that we can do, since there are only 100 columns or 100 observations, why not just save it to the first 100 of them? So 1 column 100. Yes. And the second one, 2 comma, just the regular R binomial, and 2, 1, true log theta of 2. So from a programming standpoint, is this a generalized code? Do you think this would work if I switch the order of the sample sizes, put it as 150, 100? No. So this is not a generalized code. A requirement here is, and the sample size, the first one must be less than the sample size, the second sample. Yes, so I'll put that here. We require N1 to be less than N2.
Could you make it so that, like, will it allow you to do 1 colon and then whatever the first number is from 10?
Yes. So
You can like pull that number and use it.
that's what I'm going to do. I'm going to change that to N1. So that is going to generalize it for us. But we wouldn't know which is the maximum, yes. If we have to switch the order and generalize this code, then I need a couple more steps because I have to make sure which row is longer. In order to do that, I've got to test which is higher, right? So it would require a few extra lines of code, and I don't want to do all that, right? So doable, but let's not generalize that far. I've generalized it enough, so I wrote it in such a way that N1 has to be less than N2. Good. What? Oops. The second sample is coming from Bernoulli 0.59. That is the true parameter. Table, first row. There are 70 zeros and 80 ones, right? But technically, there are only 20 zeros. We appended 50 of them, correct? The second row, I have 72 zeros and 78 ones.
Very cool. Okay, your true data and your, like when you put it in, it came out as positive, right?
Came out what?
Positive, right?
Theta? Yeah.
Yeah, I don't know why mine are coming out negative.
All right. So when we divide to estimate the probability x over n for the first case, it would be 80 over 100. Yes, p hat, because the actual sample size is 100. But for the second one, we have to divide by 150, which is n2. That gives us a probability of 0.52. Good. So we have that part done. The next would be the likelihoods. Likelihood for theta 1. We know what that likelihood is going to be, yes? What is it?
Theta to the x1 times 1 minus theta to the x1, or 1 minus theta 1 to the n1 minus x1.
I'll just put likelihood for thetas. I'm going to define theta estimate as theta dot est. Do the same trick, 0,0 for the two parameters. Yes. Of course, we have to search for different thetas and look for the likelihood, right? So theta dot est. Oh, let's see. I'll create X to be sequence 0 to 1, length equals 120. Okay, they go 512. And the next step would be to have the likelihood function for theta dot S1. We know that would come to theta 1 raised x1 multiplied by 1 minus theta 1 raised n minus x1, correct? What distribution will that be?
Proportional to beta.
Beta,
Bernoulli.
Bernoulli.
What's going on?
Theta raised x1 multiplied by 1 minus
Oh.
theta raised n minus x1.
I know.
It'll be a binomial. So instead of doing this computationally using a loop and stuff, likelihood is distributed LL for theta 1 is binomial n 1 comma theta 1 yes, but to use binom directly, the second parameter is the sample size. The last one is the search space for theta 1. Yes, that value is the sample x value that we count, right? So we know that. I'll call that sum of x to indicate it is coming from a sample. All we want is the number of ones, yes? The number of ones here would be sum of x, first row, correct? Now, I will create a temporary variable, initialize, I'll call it temp, for I in 1 to length of x. Mind you, that is my search space. Call it parameter search grid. Right? Those are the theta. Well, the theta estimate is going to fall in that interval, but that is actually my search grid. So length of x, which in our case is 512. Temp of I will be d binomial sum dot x, comma, the size, first sample, so n1, probability, that's what we're trying to estimate, so I'm just going to put example. Right, that is my search grid values. So I'm going to go through each value on the grid and plug it in the distribution to see which is going to be maximized. With me so far? Now, you may ask, well, what about the constant that is involved in the binomial? Well, if it's a constant, I really don't care, right? How I maximize it. It's just a constant. So let's run, hopefully no errors, none, which is a good thing. And now I'm going to plot x, my search grid, and the values of the density, temp, type, length, line width 2, main likelihood for theta 1 x log expression theta 1 y log okay. Let's see what this looks like. In my case, it's messed up. I get that. So it is maximizing at the value of 0.8, just as we expect. It's not exactly 0.8, but you know, and that is for theta 1. I can draw a vertical line here. I think it should just be. The expression is not going to work because it's not a standard expression. Put it as theta 1, unlike last time, but that's okay. I want to see what this maximum is, so I'm going to do which dot maximum of 10. So that is going to tell me the index with the highest 10th value. In other words, highest likelihood value. So I'll call it ID dot max. The corresponding x value from the search grid will be the theta estimate for the first parameter. So theta dot est1 would simply be search grid x. That's our search grid vector. ID dot max. Yes. Now, when I source this, I am going to get my theta estimate, which is stored in the first index because this is theta 1. So all I did is I picked the maximum value in my search grid and I got my theta x. Let me draw a vertical line. A vertical line. It has to pass through theta dot est1 color blue. I can generalize this, in a couple of ways. I could write an extensive code, but we're running out of time. So if I want to do it for both the first sample and the second sample, this is what I'm going to do. I'm going to give a choice. I'm going to change the row to be whatever the choice value is. Yes. N would be whatever I'm going to choose. X lab, I'm just going to generalize it as, theta. Again, I can write a different code to make this more generalized. But all I'm doing is I'm changing the want to choice. So I'm choosing a row as defined by the variable choice. Good. By source, it should run, and it does. And if I want to pick the next sample, I'm just going to change choice to 2. And there, I've got to change it to choice. I still have it as 1. Okay. Now, what is the key difference between this code and the code that we did, at the very beginning, when we did like-headed function and maximizing like-headed function? There, I explicitly wrote the expression for a binomial. Yes, here I'm using density function. That's it. I don't have to explicitly specify the density function if it's a known density function, known probability mass function. In this case, it is d binomial. So if you go back and look at our one parameter case, we used theta raised x multiplied by 1 minus theta raised n minus x. We used the search grid on that formula. But here I'm using built-in function d binomial. Good.